All right, guys, the next couple days of lessons are going to be practice problems, just examples for you to do along with me to see if you understand the concept. And this is what we're going to kind of do to stretch these lessons out a little bit, because in class, today would have been, maybe one day a review and then a quiz or a test tomorrow. But we're taking it easy this week just to see how everything goes. So I'll do a day of notes, and then we'll do a couple days of examples of practice problems in the days following that while you're working on the book work. All right, so we'll start off with 3 examples today. In the first one, I'm asked to find the most general antiderivative of this function. And so I think probably the best thing to do is to take this first term and put it into exponential form rather than in radical form. So 4x to the 1/2 is probably a better way to see this. All right, this is still f of x. I haven't found the antiderivative yet, but now we have to elevate each of these exponents by 1, right? So this is going to be this is going to have to be an x to the 3/2, right? Because when I subtract 2/2, which is 1, it's got to be 1/2. When I bring that 3/2 down, it's got to end up being a 4 somehow. So what I'm going to do is leave the 4 there, and I'm going to divide this whole thing by 3/2, and then you can sort of envision what would happen here if I were to take the derivative of that term. The derivative with respect to x of 4x to the 3/2 over 3/2. All right, this is what this would end up looking like. I'd bring the 3/2 down. The 4 is still there. I now have x to the 1/2. And this 3/2 down here is what's going to allow me to cancel those 3/2, leaving me with just the 4 that I wanted in the first place. So this will work for our first term. Let's see how much of this I can get rid of here. Okay. Now my second term is going to be a little easier. X to the 3rd, and what would have to go here in the coefficient spot to multiply and get a 6, it's going to be a 2 plus 3, and I have to have the x plus some constant on the end. And so this is a totally acceptable way to write this final answer. If you wanted to rationalize the denominator there, I could rewrite this as 4x to the 3/2 times 2/3. So I could write it as 8/3 x to the 3/2 minus 2x cubed plus 3x plus c. But either of those would be correct answers. You wouldn't have to write it in either of those two forms. They're both correct. All right, second example. We're going to have to remember what happens with our antiderivatives of some special functions, like our trig functions or e to the x functions. In this case, the variable is t, but it doesn't really change anything here. So when I take the antiderivative of f of t, I have big F of t. And the antiderivative of sine of anything is negative cosine of that thing. So 2 times negative cosine of t will be my first term. And remember, the derivative of e to the x is itself. So this is a antiderivative that's just going to stay the same. And you could check this and make sure that both of these terms, if you took their derivatives, you would end up with 2 sine of t minus 3 e to the t, but I'm just going to rewrite this so that it looks a little nicer. So I have big F of t equals negative 2 cosine of t minus 3 e to the t. Don't forget that there is a constant there that we're not really sure what it is yet, but we'll do an example next where we could find that constant. Okay, so just some general antiderivatives. We will do some more general antiderivatives in tomorrow's examples. Now let's take a look at one where we can find the exact antiderivative and actually get an equation. Okay, so now we're told to just find f. Not generally, we need to find that function. So we're told that f prime of x is this function 2x minus 3 sine of x. And then we're also told that f of 0, so once I do find that f of x function, I know that by plugging in a 0, I get 5. So let's find the general antiderivative first and then do some work. So f of x is going to be, well, the first term has to be an x squared term. What times 2 gives me 2? 1, so I can leave that alone. Minus 3 times, and we just saw that the antiderivative of sine of x is negative cosine of x. Okay, I'm just going to rewrite this. So f of x is equal to x squared plus 3 cosine of x. And don't forget, there is a constant there. But I now know that by plugging in a 0, because of that initial condition that was given, I will get 5. And this is going to be helpful because now I can just solve this part of the equation and find out what c is. 0 squared is 0. 3 times cosine of 0. So cosine of 0 is 1. Plus c equals 5. Okay. Now I'm just going to subtract 3 from both sides. So c equals 2. So now I actually have the exact function f. F of x isn't just equal to x squared plus 3 cosine of x plus c. It's equal to x squared plus 3 cosine of x plus 2. All right, so just a couple examples for you to look at today. We'll do some more tomorrow. Maybe I'll make that video have a couple more examples in it, but these ones are a little easier. Tomorrow's will get a little bit more challenging. And when you're watching these videos, you should pause the video, see if you can do what I just did, and then play the video and check to see if you were correct, right? Don't just watch the video and wait. You want to see if you are getting these on your own eventually. And tomorrow we'll have some more examples as well.